the Persian Gulf, the starting point of Operation Epic Fury. In the blink of an eye, a massive surge of heat ripped through the silent night, illuminating the pitch-black sea off the Iranian coast. A strangely shaped trimaran warship, its cold, gray aluminum hull cutting through the raging waves at a terrifying 40 knots. On the cramped flight deck, a rocket engine suddenly detonated. Instantly, a tiny unmanned aircraft soared into the sky. Its wingspan was a mere 8 feet. Its overall length was less than 10 feet. Inside that cheap exterior was a warhead worth less than a pickup truck. Just seconds after the first breath, a second propulsion system roared, then a third. Within minutes, a swarm of massive machines filled the air. They formed a closed combat formation, directing a barrage of physical attacks straight at the heart of one of the most fortified air defense networks in the Middle East, established by Iran. This was a fateful moment. For the first time in modern history, the U.S. Navy officially deployed a swarm of suicide drones against a real system. The most insane paradox occurred at this very location. The launch platform for this landmark attack was not a perfect technological marvel from a laboratory. It was launched from the very deck of a class of warships that the U.S. Navy's top brass had desperately tried to throw into the scrap heap. The Littoral Combat Ship, LCS, a multi-billion-dollar project that the global media had once mocked as the Pentagon's floating junkyard. Let's step back a little to look at the structure of this disastrous failure. The LCS Freedom class variant was designed around an extremely complex mechanical propulsion system. Engineers attempted to cram the power of 2 massive diesel engines, along with 2 gas turbines, into a single combined gearbox for the entire system. Theoretically, on paper, it was a design offering absolute flexibility. In terms of applied physics, however, it was an irreparable mechanical death sentence. The amount of torque generated during sudden acceleration far exceeded the material tolerance limits that the gears could withstand in the harsh environment. Throughout the ship's voyage, this gear system failed to transmit power. Instead, it was crushing itself into tiny, toxic metal dust particles. The USS Milwaukee, hull number LCS-5, completely lost its thrust on its maiden voyage, just 1 month after its official delivery. The tragedy didn't end there. The USS Detroit, hull number LCS-7, was stranded in the middle of the vast ocean, its entire system completely paralyzed, and had to endure the humiliation of being towed back to port. Admiral Mike Gilday bitterly uttered a cruel truth. This was the most challenging engineering problem we had ever seen on any class of ship. But that was only half the tragedy. The Independence-class LCS variant suffered from a completely different, incurable disease related to its structural materials. A trimaran hull design, with 3 parallel hulls, constructed almost entirely from monolithic aluminum to optimize weight and increase speed. Basic shipbuilding mathematics dictates that aluminum saves weight, and lightweight optimizes the maximum speed of a warship. But aluminum cannot withstand the material fatigue under the relentless, cyclical pressure of ocean waves pounding against the hull. Microstructural cracks begin to spread invisibly through high-load joints, tearing the metal skin from the inside. The Navy is forced to decommission these ships before they even reach half of their original design lifespan due to the risk of complete collapse. These ships were prematurely decommissioned before they were mature enough to participate in any real battles at sea. And yet, at this very moment, in the most tense opening hours of the largest naval operation since 2003, a terrifying contrast is emerging. The $13 billion supercarriers are safely anchored in the deep waters. The infamous Aegis destroyers are straining to establish an outer perimeter defense, not daring to venture further into the danger zone. And yet, this ship, riddled with fatal cracks and a self-destruct gearbox, is boldly advancing deep into the iron cage. It is carrying out a life-or-death mission alone, one that no other advanced weapon platform in the entire fleet dares to touch. Why would the U.S. Central Command entrust the course of war to a platform riddled with catastrophic flaws and technical failures? The answer lies on a deadly geographical map, the Strait of Hormuz, where the narrowest point stretches a mere 21 nautical miles. Available shipping lanes are compressed into a mere 4 nautical miles, through which 20% of the world's oil production passes daily. The Iranian military has constructed around that choke point a meticulously calculated, multi-dimensional system of destructive space. Starting in the dark underwater world with thousands of naval mines, from contact mines to magnetically induced mines. Most terrifying is the EM-52 mine, powered by a rocket engine, ready to launch upwards and pierce any passing vessel. Hiding behind the minefields is a fleet of Ghadir-class mini-submarines, lurking in the shallow waters amidst the noise, carrying heavy torpedoes. On the sea, more than 1,500 Revolutionary Guard fast attack boats are capable of tearing through the air at speeds exceeding 50 knots. Many of these are equipped with Nasr, one anti-ship missiles, operating on swarm doctrine and absolute target saturation. They pump a massive mass of targets into space to completely cripple the computing power of any defense system. Looking up at the sky, hundreds of unmanned ghosts obscure the view, creating a barrage of low-speed interference signals on radar screens. Swarms of inexpensive drones deliberately drain the data processing cycles of the most advanced American Aegis interceptor systems. Lying right behind that electronic jamming screen is the real death. IRGC tactical ballistic missiles hurtling down at Mach 3. The real deadly payload is perfectly concealed behind these cheap decoys, striking directly at the weak point in reaction time. This is a sophisticated anti-access, area denial architecture designed to exploit a single physical limitation of the U.S. Navy. The time it takes for the Aegis system to scan, detect, classify, and launch a missile is longer than the total flight time of the incoming weapon at close range. That very physical shackles permanently locked our supercarriers outside the gates of the strait. 100,000 tons of displacement steel and 5,000 sailors' lives were too great a price to gamble inside a cramped bathtub. We absolutely could not push such a massive asset into a place where the enemy had spent 40 years meticulously setting traps down to the square meter. That distance created an impossible geometric problem, requiring a physical foundation deep within Iran's death cage. The first problem was attack. The Pentagon needed a forward node close to the coastline to break through the air defense network. A mobile launcher capable of continuously dropping swarms of inexpensive attack drones directly into the radar network to saturate the interceptor system. The objective was to tear through a safe corridor for the roaring Tomahawk missiles launched from the destroyer's position in the space rear. That launch platform had to meet 4 stringent physical parameters: a small radar cross-section and extremely low thermal radiation to evade the missiles. The speed had to be maintained above 40 knots to break through the encirclement, along with a sufficiently large and stable deck to launch unmanned devices. The draft had to be shallow enough to churn up the coastal waters, where the massive American deep-sea warships were completely bogged down. The second problem was defense. The entire strait was carpet-tipped with mines, and someone had to enter and destroy them without human intervention. The traditional Avenger-class minesweepers had been decommissioned, and the replacement force had to carry robotic mine-hunting systems. Running the variables through a supercomputer. Supercarriers are too expensive. Destroyers are too valuable to risk inside the zone of destruction. Submarines are completely incapable of launching swarms of drones from underwater. Only one ship solves both equations, the LCS. But before analyzing how it wreaked havoc on its adversaries, we must delve into the flaws that inadvertently kept it alive. The answer lies within the very catastrophic engineering failures that should have sealed the ship's fate long ago. Starting with the Independence class, the trimaran's triple hull design suffered severe fracturing at the joints, subjected to extremely high material stresses. A fatal weakness that the Navy has poured millions of dollars into trying to patch for years on end. But look closely at what that triple hull geometry inadvertently created: an enormous physical supercenter height. The distance between the center of gravity and the center of mass is far greater than in the traditional monohull designs of other warships. In naval architecture, supercenter height determines a ship's torsional rigidity and its ability to withstand rolling at sea. Imagine the difference between balancing on a flimsy canoe and a sturdy catamaran. The wider the distance between the hulls, the less likely the ship is to capsize, and the more stable it remains against rough waves. A large supercenter of gravity means the ship resists all drag, keeping the deck perfectly flat and motionless. This factor is completely meaningless for a traditional warship that fires cannons or launches missiles from VLS launchers. But for a platform that needs to launch unmanned aircraft using rocket boosters from the deck, stillness is everything. The trimaran's deck now becomes an absolutely still surface amidst the roaring and chaotic ocean around it. Continuing the analysis of the second failure, the concept of quickly interchangeable mission modules at ports. The anti-submarine and anti-mine modules were behind schedule, suffered enormous cost overruns, and performed far worse than expected. The U.S. Navy was forced to completely abandon that utopian plug-and-play vision to salvage its dwindling budget. But when those malfunctioning modules were stripped away, what remained was a massive, empty flight deck. Over 11,000 square feet of unobstructed surface area, roughly 3 tennis courts combined on the Independence class. That empty deck wasn't designed to be a superior feature. It was the relic of a failure. And sometimes in war, failure inadvertently leaves behind precisely what a life-or-death struggle requires. The Navy stopped trying to make the LCS a perfect machine, instead turning it into a crude, modular node. They bolted a rocket-propelled drone launcher directly onto the deck, without modifying the complex core structure. The ship didn't need to be good at everything. It just needed to float, move incredibly fast, and have its deck wide open for any weapon system. The fractured trimaran had been transformed into the most versatile launch platform in the entire US fleet at the time. An absolutely silent deck, 11,000 square feet of free space, and speeds exceeding 40 knots. The final question was, what to throw onto that deck to completely change the course of the war in the Strait of Hormuz. In December 2025, the USS Santa Barbara, hull number LCS-32, was quietly maneuvering in treacherous waters. From its flight deck, a blazing thruster engine and a delta-winged drone soared into the air. It was the first shipborne launch of the Lucas system, the first time a suicide drone had been fired from a warship at sea. 2 months later, the weapon officially entered the dissection room, directly confronting the nation that had inspired it. Lucas is an ultimate engineering paradox, a technical reverse of Iran's infamous Shahed 136 design. American engineers at Spectre Works meticulously dissected what made it deadly. Delta-wing aerodynamics and extremely low cost. They retained the perfectly functioning laws of physics, then dismantled and rebuilt the entire core system. But what distinguishes Lucas from a cheap copy are 3 technical upgrade packages that transform it into a precision killer. Starting with propulsion, they removed the noisy Iranian engine and replaced it with the ultra-quiet DA-215 two-stroke engine. The DA-215 operates at such a low sound frequency range that the radar signal is the first warning, not the engine noise. Next is the guidance system. Lucas rejects the blind fire and forget mechanism of traditional drone versions. It maintains a continuous upload link via a Starlink low-orbit satellite constellation throughout its flight to the target. This link solves the radar horizon problem, where the curvature of the Earth blocks conventional targeting systems. Through Starlink, the command center can direct Lucas to attack moving targets beyond the horizon. Humans control the direct combat loop, but absolute precision requires a massive satellite infrastructure. And finally, there's the autonomous coordination capability, allowing dozens of drones in a formation to communicate continuously with each other. They share flight path data, automatically allocate targets, and synchronize cross-approach vectors for attack. A single Lucas is just a nuisance, but 20 of them are a computing crisis for any air defense system. Now, let's do the economics. Each Lucas costs exactly $35,000 to build and deploy. An SM-6 interceptor missile to shoot it down costs nearly $5 million, a disparity that's absurd. Iran has squeezed 40 years, building a geopolitical toll station, charging $5 million for each vehicle that passes through. Lucas simply rode a $35,000 motorcycle straight through that barrier with arrogant defiance. The cost trap Iran had meticulously laid to drain America's missile arsenal was now turning around ruthlessly. As Operation Epic Fury began, swarms of Lucas drones launched from the LCS deck, targeting key command centers. They crashed into early warning radar stations and devastated missile launchers and critical drone bases. They incinerated numerous military airfields, prompting Admiral Brad Cooper to use the word indispensable to describe them. These inexpensive drones tore through the barrier, creating massive gaps in the enemy's defenses. And right behind them, the massive Arleigh Burke-class destroyers slowly deployed their VLS launchers. The $2 million each Tomahawk strategic cruise missiles began to roar through the air. They carried ultra-precise guidance systems and massive, concrete-destroying warheads aimed at their targets. These missiles hurtled through the very empty corridors that the Lucas swarm had just opened up minutes earlier. The inexpensive drones weren't tasked with eliminating fortified targets. They simply blinded the defenses. The $2 million missile behind them would complete the job with a devastating collision. For the first time in history, the U.S. Navy perfectly synchronized inexpensive drones with strategic cruise missiles. This entire process was integrated into a unified destruction sequence under extremely harsh real-world combat conditions. And while Lucas was devouring chunks of the air defense network in the sky, a second mission was quietly underway. On the deadly waters of the strait, the USS Canberra silently entered the tense Bahrain Naval Support Base. This was the world's first Independence-class LCS to be fully deployed with the mine countermeasures mission package. The USS Tulsa and USS Santa Barbara followed suit, forming a three-platform LCS formation specifically designed for minesweeping. Each ship carried a state-of-the-art unmanned system designed to locate and destroy enemy mines. The ultimate mission was to absolutely protect the lives of the sailors, preventing anyone from entering the dangerous minefield. The MCM system operates on a single principle, but it required decades of engineering research to successfully implement. That principle is, the mothership must remain outside the threat zone. Only robotic vehicles are permitted to enter. The CUSV Standard Unmanned Surface Vehicle System, a remotely controlled boat, begins its survey mission. It tows the AN/AQS-20 mine hunting sonar system, emitting powerful sound waves to create a detailed map of the ocean floor. The sonar scans the seabed, identifying suspicious objects through shape, mass density, and even magnetic signals. The operator sits safely on the LCS miles away, simply monitoring the real-time data streams. From the expansive flight deck, the MH-60S Seahawk helicopter begins dropping two other advanced support systems onto the water's surface. The ALMDS Airborne Laser Mine Detection System scans deep into the seawater column with its distinctive cyan-green laser beams. It locates mines hovering near the surface, unreachable by sonar systems from below. Once the mine's coordinates are pinpointed, the AMNS Airborne Mine Neutralization System is immediately activated. It deploys a disposable, ultra-small, unmanned underwater vehicle, a killer robot that plunges directly into the target. 3 overlapping detection layers, combined with 3 automated unmanned systems, ensure that no crew member has to set foot in the water. Previous minesweepers forced the entire crew to operate directly inside the massive time bomb. The LCS completely eliminated that deadly variable, transforming a highly dangerous task into a remotely controlled problem. The first real-world deployment of this unmanned MCM architecture was in the Persian Gulf during Operation Epic Fury. 2 deadly missions, the same class of outcast ships, running simultaneously on a volatile battle map. One side was destroying air defenses in the sky, the other was clearing mines from the bottom of the narrow strait. Neither of these missions would have been possible just 12 months prior without the transformation of the LCS. And now, watch them converge. LCS platforms tearing through the Persian Gulf at speeds exceeding 40 knots, constantly maneuvering. This rapid movement completely disrupted any targeting solutions for Iranian coastal defense batteries. From those swaying decks, swarms of Lucas ships hurtled into Iranian airspace, obscuring radar screens. Each interceptor missile fired at a Lucas rendered it permanently unusable as a real threat. While the enemy's defense network was flooded with data and burning through ammunition, the destroyers began their assault. The cheap mass tore through the defenses, allowing Tomahawk missiles to whiz through those deadly gaps. On the defensive, other LCS platforms dropped swarms of unmanned vehicles and laser systems into the water. Acoustic waves mapped the seabed in detail, lasers scanned the water column, and swimming robots destroyed everything in their path. The entire deadly corridor, littered with 1,500 mines, was being cleared by these cold, emotionless machines. Not a single sailor had to set foot in the sea. Not a single minesweeper had to risk their life in the red zone. The results of the operation were etched into the sea. Iris Jamaran, Iran's most powerful frigate, was sunk on the spot. Satellite images confirmed the brutal truth. The massive ship's hull was half submerged right at the dock. Iris Bayandor and Iris Nagdi shared the same catastrophic fate at the same base, torn apart before they could even leave port. 3 warships were completely destroyed at Bandar Abbas, a devastating blow to the pride of the Iranian Navy. Iris Shahid Bagheri, the IRGC's homemade drone carrier, was completely destroyed physically right at the dock. The Iris Makran, a massive oil tanker converted into a mobile forward base, also suffered significant damage while anchored. But the detail that reverses this entire historical narrative is truly bitter for the Revolutionary Guard. Look closely at what we just destroyed at Bandar Abbas, the Shahid Bagheri, Iran's new pride. They spent years converting a cargo ship into a drone carrier, welding on a crude, angled flight deck. It was their deterrent response to the new era of warfare, but it hadn't even set sail yet. It was smashed to pieces right at the pier where it was born, by swarms of drones flying in from the sea. Now, turn around and look at the platform that launched the drones that destroyed that target. A 3,000-ton ship with a cracked aluminum hull that even the U.S. Congress once called a catastrophic waste of money. Iran built a drone carrier from scratch and lost it completely, while we used a scrap ship. We transformed something the whole world wanted to discard into a drone launch platform that operated with ruthless precision. This wasn't a twist of fate, it was the pinnacle of contempt for the adversary, achieved through the most merciless mathematical equations. Throughout Operation Epic Fury, over 100 warships of various types from the Iranian Navy were completely wiped out. The massive surface combat fleet that should have used swarm tactics to overwhelm us has now completely evaporated. Now you have all the factual data to answer the most difficult question we initially posed. Why the worst ship? Why the dilapidated and flawed LCS class? Because that deadly equation didn't require the world's most perfect ship with flashy technology. It required a ship that perfectly fit the physical variables, small enough to fit into the death cage, agile enough to evade any attack, and spacious enough to have a stable deck for launching drones. It had to be cheap enough so that if one were lost, it wouldn't cripple the fleet's strength. Testing those 4 stringent parameters with every existing steel hull yielded only one result: survival. That ship accomplished more than a purely mathematical equation would require in a real-world context. It launched the first drone strike in the history of warfare from a U.S. Navy warship. It deployed the first unmanned mine countermeasures system directly into a deadly carpet minefield. It operated defiantly within a destructive space that even supercarriers would never dare venture into. And it survived perfectly thanks to its speed of over 40 knots and a displacement of just 3,000 tons of steel. This size didn't generate enough radar signature to attract the attention of any ballistic missile. The engineers didn't weld up the cracked hull. They didn't repair long-dead modules on board. They simply re-entered new variables, and those flaws instantly became superior performance. The empty deck, left behind by the failure of modularity, became the perfect drone launchpad. The fractured triple hull geometry created the ultimate static stability any missile launch would covet. The dirt cheap price was transformed into an acceptable level of risk, allowing the LCS to penetrate the jaws of its adversaries. If you start seeing the dry mathematical equations instead of a disastrous failure, you truly understand. The LCS proved a brutal principle that would reshape the entire next era of naval warfare. The concept of deadly firepower dispersion was no longer a PowerPoint drawing. It was a bloody doctrine. It was inadvertently validated by a ship that should never have had a chance of entering fleet service. The future of warfare no longer belonged to the massive, perfect, expensive, and cumbersome machines of the past. It belongs to those flawed machines that are perfectly aligned, run the right algorithm, and are operated by a genius brain. Those who understand. Physical architecture doesn't demand elegance. It demands mathematical contempt. The worst ship destroyed the greatest system, simply because it was the final variable that fit perfectly. LCS was never a good ship. It was simply the right variable, and that equation worked.